Gamma Overview. First, Device Overview. Gamma is the main scanning and ground imaging tool to complete a successful 3D imaging process. Gamma has the most technically advanced systems to ground scan and detect gold, metals, and cavities. Gamma implements new high-level electronic technologies, providing new perspective and concepts in the ground imaging world. Gamma multifunction systems enable the user to perform excavations and geoscans at the widest range, equipped with all the necessary tools and apps to complete detection operations with utter success. Color display, providing the user with the programs and advanced smart functions to work on the newest scientific systems to detect and locate targets underground with full control over the scan features and the whole exploration journey path until the desired target is reached. Second, device parts. System elements. Gradio Smart sensor. Carrying pole consisting of two strong and light carbon fiber tubes. Headphones. Charge adapter. Car charger. Extra main unit fastening bolts. Imaging scanner unit and the connection unit. The main unit contains a 5-inch color display, battery pack, grip key, control keypad consisting of power key, back key, navigation arrows, OK, and quick settings access key, charge port, headphone jack, and the multifunction connector. Gradio Smart sensor, imaging scanner unit and the connection unit, handrest, carrying pole consisting of two strong and light carbon fiber tubes connected by an adjustable lock to fit the user's need. Main unit holder with fastening bolts, the tip to connect the imaging scanner, and plastic bolt and nut to fasten the scanner to the pole. Third, device assembly. Release the bolts on the holder partially. Then insert the main unit inside the holder and fasten the bolts firmly. Unlock the latch at the end of the first part of the pole and insert the second part into it according to the desired length, then lock the latch securely. Release the bolt from the tip of the carrying pole, then align the tip of the carrying pole with the imaging scanner and reinsert the bolt and fasten it firmly. Then wrap the cable around the pole and insert the connection unit in the multifunction connector. Setting the main unit position. Unlock the latch again. Adjust the position of the main unit until it is vertically aligned with the imaging scanner sensor. Then lock the latch securely. Gradio Smart sensor. Insert the Gradio Smart sensor into the multifunction connector. If the device is turned on, a chime will be heard when the sensor is connected. Search systems in Gamma. This device utilizes three different scanning and searching systems, which are 3D ground scanner, live scan, Gradio Smart. These systems use the following sensors. Gradio Smart is a multifunctional sensor, can be used with Gradio Smart search system and the live scan system. Imaging scanner is also a multifunctional sensor that can be used with either live scan system or the 3D ground scanner. Data analysis and visual representation differ depending on the search system. Ground balancing. Ground balancing the Gradio Smart sensor. After choosing Gradio Smart or live scan system, connect the designated sensor into the device main unit. The ground balance interface will show. Point the device towards the ground vertically and press the grip key in the main unit constantly while moving over the search location. Keep this process for 10 seconds. A chime will be heard indicating the completion of the ground balance process. Then the device will proceed to the selected search interface. The ground balance value can be adjusted during the search process by moving the cursor over to balance and increase or decrease it according to the ground and scan conditions. Ground balancing the image scanner sensor. After selecting the scanning system and setting up the parameters, the device will prompt connecting the imaging scanner sensor with the main unit. Then the ground balance interface will show. Align the imaging sensor so it is parallel to the ground surface and press the grip key on the main unit constantly while moving over the scan area for 10 seconds. A chime will be heard indicating the completion of the ground balance process. Tips before initiating the search. 1. Selecting the suitable location for the search system. For example, Gradio Smart system is suitable for most of the locations as long as they are free of high voltage lines, electromagnetic waves, and metal waste. Live scan system works best with flat ground surfaces. 2. Keep a 10 to 15 centimeters clearance distance between the bottom of the imaging scanner and the ground surface. 3. If the search is taking place in a closed housing, the electricity must be cut off first. 4. The user should remove any jewelry, metal accessories, watches, etc. before starting the search. How to use the search systems. First system. How to use Gradio Smart system. The search interface will be displayed once the ground balance process has concluded, and it contains Voids indicator. The void indicator gives the user the accurate result about natural earth cavities or tunnels inside the scan area. Metal indicator. The metal indicator gives the user the settled results about the metal location and density, whether big or small. Sensitivity indicator controls the device receiving sensitivity level of the magnetic signal from the ground. Sensitivity level can be adjusted to account for the location and soil conditions. Balance indicator displays the ground balance value of the initial ground balance process that has been made. It can be adjusted to get an accurate balance ratio for the search location. Press OK on the indicator to take an auto value for balance, or press up or down arrows to increase or decrease the value to get a more accurate balance to the search area. Waveform window shows a graph demonstrating the received signals by the device. The graph expresses the target size and location, which gives the user a prediction about the target size and bounds. The red color in the graph represents metal targets, and the blue color represents the cavity targets. Delta indicates the received signal intensity percentage. It assists in balance process by changing the balance value manually or automatically to be between 0 to 3, red or blue. Note: if the designated sensor is not connected prior to accessing the system, a prompt will be displayed to connect the sensor first to proceed to the system. How to work and search with the system. After setting up this system and balancing the ground as mentioned earlier, the user holds the device by the grip perpendicular to the ground with a clearance distance of 10 to 30 centimeters and start walking and swinging the device right and left in moderate speed, while observing the display for any changes in the metal and void indicators and watching the waveform graph in addition to the delta value, which expresses the signal intensity. In the case of target's absence, the indicators will remain relatively stable. If a target is detected, a change will be noticed in these indicators. Target validity and presence are determined by the high values of the indicators above a certain point. Depth. Once the target signal is received and located, move the cursor over the depth icon and press OK to access the depth meter interface. Press the grip key and point the device over the target point as shown in the figure. Move forward in a straight line until the device is finished analyzing the depth depending on the faint changes of the magnetic field. The target depth will be displayed in the estimated depth window and the arrow will move to the corresponding value. Save. The search results can be saved with the date and time in addition to the location coordinates as displayed on the interface. Second system, Live Scan System. The ground balance prompt window will show when this system is selected. Do the ground balance operation. Once the ground balance process is done, the device will proceed to the system interface automatically. Multiple configurations can be set to get highly accurate results. Setting up the system for search. As mentioned earlier, this system works with both sensors, either the Gradio Smart sensor or imaging scanner. Each sensor has its own setting interface, which will show once the sensor is connected to the device. A. Scan speed. This feature provides accurate control for the scan speed to fit the search requirements and the user mobility speed. B. Live scan using the Gradio Smart sensor. The interface shows two options when the Gradio Smart sensor is connected: gain and balance. While connecting, the imaging scanner only shows balance without the gain setting. C. Balance indicator. This indicator takes its value automatically after doing the initial ground balance upon accessing the system. Manual adjustment can be done by moving the cursor and increase or decrease the balance value with the up and down keys to get an accurate balance with the scan area ground. An automatic value can be obtained for the ground balance indicator by pressing the OK key. D. Gain indicator. If the Gradio Smart sensor is connected, the user can adjust the system gain intensity according to the conditions and features of the scan area. If the ground has a higher magnetic flux, it's recommended to lower the gain level to get accurate results. If the system is stable at a high gain level after completing the balance, then the system can be used with higher gain levels. E. Output windows and start pause icon. The window shows the live imaging results, where it clarifies the target's bounce once it is passed over, exhibiting the target distance and the spread area of the target over the scan area. Press the grip key and the start pause icon will toggle, then the live scan will start. How to work and detect with the system. After setup and completing the ground balance as mentioned earlier, the user holds the device and points it towards perpendicular to the ground surface, keeping a clearance distance between the sensor and the ground of 10 to 30 centimeters. Then the user should start walking in a straight line with moderate speed back and forth in the searched area while observing any changes to the output window that can indicate probable targets. If the search area is free of target objects, the output window will be stable at green or green shades. In case the system detects a metal target in the ground, a red color would appear in the output window. This color will appear starting from the user passing above the target until the target is passed. The color might be a gradient between red and orange if the target is deep. As for detecting and sensing voids and cavities, the system will show blue color or blue gradient depending on the depth of the cavity. The color will be displayed from the start of the cavity to the end, in which the user can identify and locate the target and estimate the size. Note: if the user notices a disturbance in the colors or instability, then the ground type might have changed and the user passed the location where the system was balanced. So, the user should rebalance the system with the ground, taking notice that the balancing process is done away from the probable target's location. Third system, 3D ground scanner. When the system is selected, an interface will show two scan scopes to choose from: device and tablet. The device option displays the results on the device screen directly, while the tablet option interfaces with AJAX analyzer to provide more comprehensive scan and 3D views. First, scanning with the device. There are multiple steps that should be made prior to initiating the 3D ground scanner. A. Scan mode. The options interface shows two scan modes: automatic and manual. The difference is that the automatic mode takes the readings without the need to press the grip key, where the manual mode requires the user to press the grip key to obtain a step reading. B. Scan path. It can be set in one direction, where the user scans the columns from the bottom to top. The alternating path scans the first columns from bottom to top, then the next from top to bottom, and so forth while maintaining the same orientation. C. Scan step. Sets the intersecting lines to form a grid covering the scanning area. The intersecting lines form individual cells and the size is 30 by 60 centimeters. The forward step during the scan process should not exceed 30 centimeters, and the sideways step between columns should be 60 centimeters, which would give a cell size of 30 by 60 centimeters. Here is an example. Set the device at 10 rows and 5 columns. To get the scanning area in square meters, do the following calculation. 30 by 10 rows equals 300 centimeters, 3 meters in length. 60 by 5 columns equals 300 centimeters, 3 meters in width. So the overall covered area according to the given parameters is 9 square meters. D. Start point. Sets the starting corner of the scan, which gives the user the comfort of use with both hands, or the scan location might not allow starting from one of the directions. For example, select starting from the right. Once all the parameters are set, the system proceeds to the ground balance interface, which explained earlier. After completing the balance process, the system shows the scan interface with an empty grid. How to work and scan with the system. Once all the system parameters are set, get ready at the starting point and press the grip key to start the scan process. Press the grip key once and start walking in equal steps, and press the grip key after every step if the manual mode was selected to capture readings at every cell. But if the automatic mode was selected, then match the steps to the audio signals from the device. Note that when working with this system, the user must follow the scan path that was selected either one direction or alternating, and moving to new columns when the current is finished, which is indicated by a chime informing that the column is filled. Continue with the same procedure until the scanning grid is filled completely. Note: the user should follow and comply with the selected parameters and settings to get accurate and ideal results. After completing the scan process, a graph forms on the interface representing the scan data in different colors. Each expresses a specific target detected by the system. Output window is a grid based on the scan step parameters set earlier in the process. The grid shows the scan data in three spectrums, which are: red indicates the presence of metal target, green indicates the ground surface and soil, blue indicates the presence of cavities, voids, tunnels, and closed empty volumes, even sewer pipes, while electricity lines might be a combination of red and blue. On the bottom of the interface, there are 5 icons representing specific functions, which are: A. Scan processing icon calculates the scan grid to get a high-resolution graph for the scan once it is conducted. B. Magnifying glass icon shows an overlay grid representing the capture points by the imaging scanner, which contains 4 accurate sensors, each covering a 15 cm radius area, giving a 60 cm overall covered area. C. Filter icon moves the cursor to the top left corner on the interface to filter and isolate the 3 spectra. The red spectrum represents metals, and the blue spectrum represents cavities. Green spectrum represents ground. D. Save icon stores the captured results to be browsed and analyzed later. The device can save up to 999 entries. Press OK to save the current scan. A check mark will appear on the icon indicating that the scan was saved successfully. E. External device icon. When the scan process is completed or browsing a previously saved scan, the device can be connected to an external device by AJAX Analyzer application via Bluetooth. Press OK to browse the scan on the application for further analysis options. Scanning with tablet. Connect the imaging scanner. Select Tablet Scan from the 3D ground scanner. Set the scan parameters as needed. Do a ground balance over the scan area as mentioned earlier. Once the ground balance process is over, wait for the data to be processed and turn on the Bluetooth if it is off. A window prompting the connection to the tablet shows next. On the tablet, go to Settings. Go to Connections. Turn on Bluetooth. If it is the first time connecting the device to the tablet, a pairing process is needed. Search for nearby devices and wait for the device to be listed in the available devices list. Tap on AJAX to pair it. Enter 1, 2, 3, 4 as a Bing code. Once the pairing process is done successfully, launch the AJAX Analyzer app. Tap the Connect button at the upper left corner and wait for the connection to be established. A window prompting the start of the scan shows. Start the scan process with the selected parameters. When the scan process is finished, enter a name for the scan at the upper right box and tap Save. Specific scan values can be filtered out of the display by the buttons on the right. Default shows the full scan date. Remove Metal shows the scan data and filters out the metal values. Remove Caves shows the scan data and filters out the cavity values. Filtering. The visualization can be smoothed using the filtering feature to show a gradient view of the scan. To show a specific cell value, use the arrows to locate it. The cell values are shown on the right. Direct input for the cell position can also be made at the bottom of the right. Enter the row and column, then tap Go to locate the cell directly. The 3D plot shows a three-dimensional surface representing the scan data values. Different views can be selected from the right, as filtering out metals or caves values. Swipe over the surface for a custom viewing angle. Details show the scan information, including the scan parameters selected by the device, scan date, scan direction, overview of the values, and the scan location. The scan location is not stored by default. To store the location of the scan, enable the location services from the settings in the tablet and tap on Show Refresh Current Location. Saved scans shows a list of the scans stored for review and analysis. The tablet scan is identical to the device scan but features an easier interface with a clearer representation and enables the user to scan a larger area of ground.